So in today's lesson, you're going to be learning some common algorithms for working with numbers. And when you learn these algorithms, it's important to keep in mind that when we work with a computer, it often looks like computers are really smart. It seems like computers can do so much more quickly than humans can. But the reality is that computers are actually kind of dumb. They can only do exactly what you tell them to do. And so algorithms are basically a set of instructions that you're writing that teaches a computer how to look smart. But in reality, you're the smart one because you're the one who's going to be designing the instructions that tell that computer what to do. In this video, we're going to look at some techniques for building algorithms working with numbers. So in lesson 1 of this unit, you were introduced to the while loop. And all the algorithms that we build in this lesson are going to be things you can build using a while loop to solve problems that basically involve operations on numbers. And after you've practiced with these techniques and building these algorithms, then you can go off on your own and try the challenge problems. All right, so before we actually jump into loops, I wanted to demonstrate a very simple algorithm here, which is just using an if statement and a few inputs to check if A divides B, and I'll say evenly, just to be very explicit, that what we're talking about here is dividing B evenly. So we enter a number A, we enter a number B, and then if we check here, if B mod A equals 0, if this is true, then that means that A divides B evenly because there is no remainder. Let's try it. For A, we'll choose 2. For B, let's choose 6. And great. It says A divides B evenly. This is an algorithm. You might not have thought that an algorithm could be so straightforward, just a few lines, but if you didn't do these steps in this exact order, then you wouldn't get the correct result. Then you wouldn't have checked if A divides B evenly, and checking if a number is divisible by another number is a math problem you've probably done in your classes before, and it's very much considered an algorithmic thinking problem. Now I want to introduce a helpful variable that you can use in some of your programming algorithms, which is called a flag. All right, the flag is essentially a binary variable. You could use a Boolean if you wanted to, but I find it a little easier to use an int. And basically what the flag does is it's going to tell you what the result of a conditional was earlier in your program so that you can then use that later. So the idea here is it's like a flag. If it's raised, it's a 1. If it's down, it's a 0. And you can use that information in your program to make decisions later in the program. So I'm going to do sort of a simplified example of using a flag for now. Let's just say that instead of checking for divisibility, we wanted to check for equivalence. We wanted to see if B equals A. And instead of doing my printout right away, instead I'm just going to set my flag equal to 1. All right, and then I'm going to cut out this print statement and move it a little lower, and I'll say, okay, if flag equals 1, then, now I'm pasting that print statement back in, make sure all your tabbing looks good. Then we're going to print out A divides B evenly. Oops, this is from our last challenge. A is equal to B. All right, I know this seems kind of straightforward, but I promise we're going somewhere with these flags. It's just I want to build it up slowly so you can understand that a flag is just collecting basically the answer to a question, and then we're using the flag later in the program to control what happens. All right, it's basically a way of delaying the result of an if statement. Okay, so if I run my code and I want to just double check that everything does work, 2 and 2, A is equal to B, perfect. Now let's try using this flag with a loop where it will become more useful. So now we're going to practice using this flag in a while loop and basically allow a person to continue entering numbers. So I'm going to add my while loop here, and I'll say while flag is equal to 0. So basically while they haven't entered equivalent numbers. And then I'm going to now tab this in so that my if statement's inside the while loop. If B equals A, then I'm going to set flag equal to 1. And then this is the important thing, is that if they didn't get it with 2 equivalent numbers, I want to allow
the person to enter another number. And so I'll say enter B again. And scan in another number. It's sort of like a guessing game here, where a person is going to be able to essentially try to keep entering numbers until they find one that's equal to A. And then once they do, we'll let them know that they've found equivalent numbers. Okay, so this is how a flag can basically sit inside the while loop, and we can just keep looping as long as it's 0. So I can try running my code here, enter A to be 2, let's say B is 3. Enter B again, 4, no, 5? What about 6? What about 2? I forgot to go the other direction. Great, A is equal to B. So our flag variable essentially controlled this loop. Now, some of you might be clever enough to notice that, well, you could have just said if B equals A here, while B does not equal A, to do this loop. That's correct, but I wanted to demonstrate using a flag because now we're actually going to change it. And instead of using a flag, we're going to use a count variable. Because count variables are different than flags, but they kind of act the same way in that you create them outside of the while loop, but they perform a task inside the while loop that's going to basically keep track of how many times something was true. And this is different from the flag in the sense that now we actually will have our normal control of the while loop, but this information is going to be available to us after the while loop so that we can keep track of whatever it is that we counted. To demonstrate using the count variable, I'm only going to need one input variable, so I'm just going to get rid of B for now. And I'll use A, but I want to allow the person to keep entering numbers this time. So I'll say enter A or -1 to stop. So this basically is going to allow a person to keep entering, and now my while loop condition will be as long as A does not equal -1. And then inside of here, let's say for this algorithm, we wanted to just check how many numbers they entered that were less than 10. All right, so I'll say if A is less than 10, count plus plus. Remember that operator is going to add 1 to our count. If A was less than 10, I add 1 to count. But then I also want to allow the person to enter another number if they want to, so we can keep track of how many numbers they've entered that were less than 10, but not -1. Okay, so I'm going to now copy this code down here and give them a chance to enter another number, enter A or -1. And I don't have to declare A again because it's already been declared, but I now set it equal to scanning the next int. And now this loop will go back up and repeat again. And then at the very end, I don't need an if statement for this, but I'm just going to let the person know how many numbers they entered that were less than 10. And I'll say, okay, you entered count numbers that were less than 10. All right. And, I need to make sure I add these two together to concatenate those strings. And let's try running this program. Okay, so enter A or -1 to stop. I'll enter 3. Enter A or -1 to stop, 5. How about -10? And now I'll stop. So I should hypothetically have 3 numbers that were less than 10. Great. That is why a count variable, which is very similar to a flag, can be useful inside of a while loop because it helps us to keep track of information that we're accumulating as we loop. Okay, I think that's enough information for one video. I'll be back with a couple algorithms that use a flag or a count or some type of tracking variable. For now, I want you to just take a minute and try to process this information and look through the summary to see if you can connect what I've shown you in this video with what you're reading.